Okay, in this section we have 1-4 angle bisectors with algebra. So in our very first example, we see here we've actually been given an angle bisector construction. We know it's a construction from these little bitty curve marks. And of course, when you come back into campus in person, I'll teach you how to do these constructions using a protractor. Now, notice angle bisectors mean that this angle has been cut in half. So we know that this angle is always going to be congruent to the bottom half. So we're given angle ABD, which we see is the top part, and I'm going to label that the part. And we're given also angle DBC, which is another part. And what do we know about an angle bisector? It cuts the angle into two congruent pieces, so we can actually write the congruency statement. Angle ABD is congruent to angle DBC. Well, this allows us to set up our first algebra equation. We can say, okay, well, angle ABD is 4x minus 6, and we'll set that equal to DBC, which is 2x plus 1. And now all we have to do is solve for x. Remember, we're going to move our smaller x first, so minus 2x minus 2x. We're subtracting because we're getting rid of the positive 2x, and of course 4x minus 2x is in fact 2x. 2x minus 6 is now equal to 1. So we add our 6 to get rid of our subtraction. Now I have 2x is equal to 7, and of course we finish this off by dividing both sides by 2, and this will give us x is equal to either 7 over 2, or if you want to use a decimal, which I would encourage, 3.5. So we have our answer, x is equal to 3.5. Now, what about this question right here? Solve for angle ABD. Well, switching it up, we see that angle ABD is this right here, and it's denoted by 4x minus 6. So we can say this, angle ABD is equal to 4 parentheses minus 6, where in place of x, we'll plug in our 3.5, which we just discovered. So if you were to use your calculator, you would see that angle ABD is equal to 4 times 3.5, which would be 14 minus 6, and 14 minus 6, of course, equals 8. So so angle ABD is actually only 8 degrees. And here we have something interesting. The way I drew this angle, it looks like it's obtuse, but if this is 8 degrees, and this angle is congruent, which means it's 8 degrees, that would mean that the total would be 16 degrees. Did I draw this correctly? No, because obtuse angles should be greater than 90. So sometimes we can have geometry problems that actually are not realistic when you... Here we are in example 2, and we're actually given that ray SA, and notice that I said ray SA because it has one arrow, is an angle bisector. Now, what does an angle bisector imply? Well, it tells us that angle WSA is going to be congruent to the other half of the angle, angle ASH. Now remember, I can use one arc for each one of them, or I could use 2 arcs for each one of them, or I could even use 3, so long as they have the same number of arcs. But in this case, this is actually slightly different than our previous problem. So let's notice something here. Angle WSH, W to S to H, that is actually the whole angle. And angle WSA, WSA is a part. Or in this case, whenever we're talking about bisectors, it's a half. So what does that really imply? Well, let's kind of label this angle the way we should see it. We should see that our whole angle is 8x minus 3. We should see that our top angle is going to be 3x plus 12. And you know what? I didn't write this initially. Let's just say this. 1, I want you to solve for x. And 2, let's say I want you to find angle ASH. Okay, how would we begin to do something like this? Well, we want to start by first writing our congruent statement. So what if I wrote the statement angle WSH is congruent to angle WSA? What would you say? True or false? And I would hope you would say false. The whole is not equal to the part. There's no way these two things are equal. So a great question would be, how many parts or how many halves does it take to make a whole? In this case, it would be 2. So we could literally write the whole thing, 8x minus 3 is equal to 2 times the half, 3x plus 12. Now from here, let's go ahead and solve for x. We know that we have to start by distributing, and so we can have 8x minus 3 is equal to 2 times 3x, which would be 6x plus 2 times 12, 24. From here, you always move your x's first, and which one should you move, the large or small? In this case, we want to use the small x, so we'll subtract 6x from both sides, and of course 8x minus 6x will give us 2x minus 3 is equal to 24. Now from here, if we want to get rid of the 3, to get rid of subtraction, we add, and so we wind up with this. 2x is equal to 24 plus 3, which is 27. And if we divide both sides by 2, we actually get a pretty good answer. X equals 27 over 2, or we could write this out simply as x equals 13.5 if you wanted to use the decimal. Now, for solving for x, I'm a-okay with using fractions, but if you're ever going to plug the number in, I would highly recommend using the decimal. It's a little bit easier in the calculator if you're going to use that route. So here we have angle ASH, and for angle ASH, we see here angle ASH is this bottom, and I would ask you, which one is this congruent to? Is it congruent to the top half, or is it congruent to the whole thing? And hopefully you would say that this half is congruent to the top half, and so we could simply write this 3 parentheses plus 12, where we know that our x value is 13.5. Now I'm no math major, but I believe 3 times 13.5 would be 39 plus 1.5, so that'd be 40.5. If I'm wrong, let me know in the comments. And 40.5 plus 12 would give us 52.5. So angle ASH is equal to 52.5 degrees. All right. Oh, and by the way, one other thing. If angle ASH is 52.5, what about WSH? Well, that would be 52.5 again. And wait a second, if you add up both of those, you would get the whole thing is 105 degrees. Did I draw this one properly? No, because it should be drawn like an acute angle, or I'm sorry, like an obtuse angle, and I drew it as it was acute. Silly Mr. Hastings, 0 for 2. All right. Well, I hope this helps. And I have one more quick example leading into the next section to help you out for review. But good luck, and I'll see y'all there.